Okay, good afternoon class. So today we're looking at Trigonometry chapter 7. Also we're looking at the examples for exercise 7.2. Exercise 7.2 is on page 226. Today we're looking at trigonometric identities. Okay. To 25. 6. The examples on page
226.
226.
That explanation is on 225.
Okay, it's fine. Seven. Okay, so trigonometric identities. A trigonometric identity is a mathematical statement that is true for all values of the angle except for those for which the statement is undefined. When is something undefined? When you're dividing by 0, when the denominator is equal to 0. Okay. The two fundamental identities are as follows. So you guys have made this notes already. Tan can be written as sine over cos, and sine square theta plus cos square theta is 1. Okay. So I can derive another formula from here if I make sine the subject of the formula. Take that over. So sine square theta equals 1 minus cos square theta. Can you see that? Likewise, cos square theta is equal to 1 minus sine square theta. This is called your fundamental identity and this is called your squared identity. Okay, I see they're calling it both fundamental. Okay. Fundamental is very important, okay? The basis of many things. Fundamental. Okay. Two identities can be proved using definition of ratios as shown. People, if you're that kind of girl that wants to know everything, then I suggest you go through the proof here, okay? You want to know who the daddy is and all of those things, no? You can go through that example. Or the explanation of how they get that. People, I'm looking at example 1. Example 1 is on page 226. Alright, first question. The question says, use the fundamental identities to simplify the following expressions. So what was the fundamental identity? Was firstly, tan theta is equal to sine theta over cos theta. And sine square theta, sine square theta plus cos square theta is equal to 1. We're going to use that in our proofs now, okay? So if you're looking at the first one, A, tan theta times cos theta. Tan theta times cos theta. What can be done here? Sine tan. You can change tan to sine over cos. So it's going to be sine theta over cos theta times cos theta over. So what happens? Cancel. So I'm left with sine theta over 1, which is? Okay, you guys understand? Simple, no? Let's look at B. B, you got 1 minus sine square theta over cos theta. So what is 1 minus sine square theta also equal to? Cos square theta. Remember earlier on we just what I said? We take that over the equal sign. Then you got cos square theta is equal to 1 minus sine square theta. Or we say that 1 minus sine square theta is equal to cos square theta, or sine square theta is 1 minus cos square theta. So this we can replace with cos square theta. So we have simply cos square theta over cos theta. So what happens now? Cancel. So the answer is cos theta over 1, which is cos theta. See any confusion there? You guys understand, huh? Alright, so okay, let's carry on. There's a C as well. Okay, so let's take this back. Let's look at C. In C, we got sine x plus cos squared x over sine x. So what are we going to do here? We're going to find an LCM here. Not so. So what's your LCM between 1 and sine x? Sine. Okay. So 1 multiplied by what is sine x? Sine x. Times that by sine x. Not so. So sine x multiplied by what is sine x? So sine x multiplied by sine x? Sine squared x. And plus, because there is a plus thing. Cos squared x times 1 is? Cos squared x. Yeah, but I wrote theta by mistake. Then they give me a chance to make a mistake. So what is sine squared x plus cos squared x? 1. So this answer is 1 over? Easy, no? Easy. People, let's look at D. You got sine x over cos x plus cos x over sine x. What's your LCM here? Sine x cos x. So what must this be multiplied by? Sine x. Okay. But also by sine x. What must sine x be multiplied by to get this LCM? Cos x. Okay. So sine x times sine x? Sine squared x plus. Cos x times cos x? Cos squared x. And what is sine squared x plus cos squared x? Is 1 over sine x cos x. Yes?
Why doesn't the x become squared? Because it's multiplying
No.
2 x's.
Look at that. He's asking why doesn't the x become squared? Yes, Luditi? Good question. Okay, the reason why it becomes square is because if you look at sine x times sine x, what is x times x? That is x squared. No? Now in x's place we have a sine x. Imagine that now in x's place. So in other words, that's going to be sine x squared. Not so. Now the shorthand of writing this, the simple way, or another way of writing this is sine squared x. And that is why the square is not lying in x. You understand? So later on when you see cos 5y, that actually means cos y, and that answer must be to the power of 5. That is why if you pull your calculator up and you try and put sine squared, you see there's no way I can put the square here. You see that? Because the function is not being squared, like sine squared x. The function is not being squared, like sine is not being squared. It's the answer of sine x that's being squared. The answer of cos y is being raised to the power of 5. Make sense? Next. Any other questions? Right, let's look at the next one. Next page. 227. Example 2, page 227. So here we are asked to prove the following identity. as we said, we gave a definition of the identity earlier on. So this is not an equation like we take things over the equal sign and so on. We must prove that the left hand side of the equation is equal to the right hand side. So let's go. The left hand side. What can happen if we look at the two? Which of the two is more complex? The left hand side. That's why we're going to simplify the left hand side to look like the right hand side. People, there's a way that I can go from there to there, but it's more difficult. Okay. Alright, so what do we do? What can happen in the numerator? Multiply. So 1 times 1 is 1. 1 times sine x is sine alpha, sorry. Negative sine alpha times 1, negative sine alpha. And that's going to give you negative sine squared alpha. And this is all over cos squared alpha. So that cancels, not so? 1 minus sine squared alpha over cos squared alpha. So what's 1 minus, right, the fundamental identities again? Is that tan alpha is equal to sine alpha over cos alpha. And also, sine squared alpha plus cos squared alpha is equal to 1. So what is 1 minus sine squared alpha? Cos squared alpha. So I got cos squared alpha over cos squared alpha. What's cos squared alpha over cos squared alpha? 1. Okay. Which is equal to the right hand side of the equal sign. Where do we get LHS? It's the left hand side of the equal sign. Okay. Any confusion there? Let's do it again. No. Okay. Nice. Right, let's do the last one quickly before the bell rings. Am I moving too fast? People, let's look at the B quickly. Which side is more complex to work with?
The left hand side.
The left hand side. We work with the left hand side. It's going to be not complex, but it's going to actually be easier to work to prove the right hand side than going from the right hand side to the left hand side. Again, there is a way of doing it. Okay? But it's just more complex. Alright, so I'm going to work with the left hand side of the equal sign. So left hand side. What can happen here? What can you change here first? Tan. Alright. Tan can be written as sine theta over cos theta times cos theta over. Now what can I do? How many terms are there? Hi. 1, 2, 3, 4, 5, 2 years. What separates terms? We did this in grade 8. Okay, so there's 2 terms. So what I need to do is I need to first simplify this term. Okay. So there's 1 minus. What can happen here? Cos cancels cos. So what's sine theta times sine theta? Sine squared theta. What's 1 minus sine squared theta? Cos squared theta. Which is equal to the right hand side. We're not going to conclude like we did here. You're going to lose a mark. People, with that you should be able to have done exercise 7.2. The full lesson can be found in the description box below.